a cumulative percentage of people who lives within a certain distance of a green space area. So we can say the analysis after like when we will do it, like 60% of people are living within the 600 meters. 90% of people are living within 1 kilometer. So it is a big picture to view how workable the city is. Hey GIS enthusiast, welcome back to Native GIS. In today's video, we are diving into a fascinating urban analysis project where we map urban green space accessibility using Python and GIS tools. We'll calculate how far people live from green spaces. So here green spaces means we can say parks, uh, areas which you can walk, all those spaces, and visualize which area are undeserved. Okay, let's get started. Now we'll be going to what is the project objective and the real world relevance of this particular project which we are doing. So why does green space access matter? Parks and gardens reduce urban heat, improve mental health, and support social well-being. But not every neighborhood has walkable access. In cities, green spaces, desert can affect people's quality of life, and especially in undeserved neighborhoods. Uh, by mapping access to the green space, we can help urban persons to urban planners to identify like areas that need to have more parks and more recreational areas. Okay, here our mission will be to analyze how accessible green spaces are within the 2 kilometer zone. So here now we will be discussing what are the tools we are using. Okay, so to start, we'll use few Python libraries that are perfect for this task. One is OSM NX, that is for downloading OpenStreetMap data and like roads, networks, and green areas. The second tool is GeoPandas. It will be like manage. It will be used for manage and analyze the spatial data. The third tool which we are using, that is Network X, to perform network analysis and measure distance along streets, or you can say calculate shortest walking distances. The fourth tool which we are using, that will be Matplotlib and Folium. So that will be used to visualize our data and add base maps. And all of these tools will be running in Google Colab environment. So no setup will be needed. It will be a very you can say that it will be accessible to everyone. Okay. Now let's go to the another section that will be defining the study area. So we'll be focusing on the area of Berlin, and by the end of this video you will know how to evaluate walkability to parks and how to use data for urban planning. Okay, but so we'll be going to the next section. So as before going to another video, means another section, sorry. uh, before going to another section in this project, I just want to tell you that I have already created some GeoAI videos, which links will be in the top. You can say it will come over here in the I section. You can click it and you can go and checks. So there I have discussed how to open Google Colab and how to do that. So you can follow those things. Okay. So now what we'll be doing, we'll be installing the. So here what I have done is I have already done this project in Google Colab environment. So I'll just go through the steps. Okay, what I have done, and what all things I have what all things I have done, and I'll explain them. Okay, so that's what I was telling before. Like if you want a full video, a live session, so we can do a YouTube live, but you guys need to be uh, telling in our comment section like if you want those video or not. Okay, then I'll set up a live video and we can sit and we can work on it. Okay, so till then, let's go and let's get started, like what things need to be done. So the first thing will be install the dependencies. Okay, so here this is the code for installing the dependencies. If you'll go to Google Colab and you will see, we'll just write this code, install geopandas, OSM, NX, network case, matplotlib, and context, and after that, once that's done, means then we'll be importing the this particular libraries. So here if you'll see that, uh, import OSM NX as OX, we'll write this particular part. Okay, after all these things has been done, so what you need to do is we need to be defining the area of interest. Okay, so we'll define our area of interest as I told before, like that's Berlin Mitte, and we can define a center point, Berlin's Brandenburg Gate, and use a 1 kilometer radius. Okay, so I have used 1 kilometer. You can use 2 kilometer, 5 kilometer, 10 kilometer. This boundary will help us to filter roads, green spaces, and sample home locations, buildings location basically. Okay, so here if you'll see, like the central point in Berlin Brandenburg 8, that's latitude and longitude of it. And then after that, here we have provided to create a bounding graph of 1 kilometer radius, OH dot graph from point, latitude, longitude, this latitude and longitude points will be there, distance will be 1 kilometer as I have said, then network type will be WAC. Okay, then you can see to plot this figure of that street network which we have done as this, and it will generate, it will plot the street network after that. Okay, so using OSM NX, we download the street network of Berlin Mitte. Since we are interested in walkability, we set the network type to walk over here. Okay, here we have network type as well. The walkable street network, green spaces tagged as parks, garden, etc. So we'll be doing that in the future, means in the next course. So after plotting the street network, then we have, you can say that after doing that, we have now will be focusing on the green spaces. Okay, that will be parks, garden, and other open, you can say open spaces. We'll extract their polygons from the OpenStreetMap and using this tags feature, that will be already, those particular things will be already in the OpenStreetMap, but we'll just get the attribute and we'll be plotting them. Okay, so if you'll see over there, like we need to write this tags, laser, and this will be, you can say, object. Inside that, this is the park, garden, recreation ground, and nature reserve. These are all the open areas where the green space availability is there, right? So to get the green areas, polygon geometries, we means use OX dot features from point instead of OS geometric from place. You can do that. So suppose in between, like if you are pasting a code which is not working, Google Colab will replace that as well, which can be run over here, and you can run that. So after that, we'll be finding the green spaces. Okay, uh, after that, so basically here it is doing for the 1000, sorry, that need to be changed to 1000 over here. Okay, and then Before I was doing for 5 kilometer distance, but it gave took lot of time. Okay, so that's why I reduced to 1 kilometer, and I am doing the analysis in 1 kilometer. You can do it 2 kilometer, 5 kilometer based upon your PC performance and the PC or that which you are using. Okay, then after that we'll be having the multi polygons, and basically we are changing the coordinate systems to 3857 based upon the which area you are taking. So you can do analysis based on your areas as well, and you can do the plot analysis over there. So here is the, you can say that this is the green space availability. Uh, this is the green space availability which we have got. Now the thing is, what is next? Okay, yeah. So now we'll be going to the next section of our code, that is that will be stimulating the residential points, or you can say the building areas. Okay, we'll generate residential points that will be loading from OSM, building tags as a residential. Since we don't have actual home locations, we'll simulate around 100 to 200 random points inside that study area which we are taking inside that 1 kilometer distance, whatever the things we'll be having. Then these represent where people are living, right? So this let us to model the accessibility, realistic thing which is protecting the privacy as well. We stimulate residential locations, think homes and apartment buildings within our study area. Okay, whatever we're taking. We generate random sample points, filter them within the buffered area of the polygon which we are taking, and treat them as peoples we want to analyze. Okay, so for that the code will be like import random from sapli.geometry, import point and polygons from sapli.ops, import unary union. So here you can see that we write this thing, I give the buffer area as 1 kilometer, and after that you will see these are the points of the residential points inside that 1 kilometer uh, which we are taking. Okay, then what we'll be doing, we'll be changing their uh, changing them, that residential and green spaces geometry to 4326. Okay, then we'll be getting the nearest. Now we'll be going for the shortest distance. Okay, so for that, what means, here comes the magic. For each residential point we find the nearest green space node on the street network. Then we use network X, okay, to calculate the shortest walking distance, not as profiles but in real world points. Okay, we store the results in meters and kilometers. Okay, that will be checking. So here I have we are taking the centroid of the park centroids whatever we have, and as I said, we'll be taking the distance of those from the nearest green space node on the street to the residential point which we are having. Okay, so here, as we'll be converting the points to nearest network nodes, so it will convert the nodes to the nearest network nodes which we are creating. After that, we can see that okay, CRS, the centroid are likely correct. So this is error, you will not be worried for that. Then what we'll be doing is to use uh, to calculate the access distance, the shortest path you can say. Then we'll be using distance, this particular part, this exactly, and we'll be calculating the shortest distance between uh, each green space node, green space and the building node. Okay, so it will be calculating the shortest distance and then it will be doing that. So based on that, so if you'll see over here, so it after running this, okay, actually this particular part takes time. Means if you increase the area from 2 kilometer or 5 kilometer or something, it will take time as whatever timings you have taken. Okay, then after you got the notes and everything, then we are converting into a visual interactive map. So you can say that that map uh, will be creating for through folium libraries. So latitude, longitude, zoom you can give, and then we'll be adding the green spaces as a green, and we'll be adding the residential points as blue. Okay, so here you can see that, so this is the map which we got. Okay, now after this is exact the map which we are talking about, and then after that we can get it through the geogestion. Okay, then now we'll be going to analyze it. Okay, how it is being doing, so that will be the analysis part. So let's go to the analysis of the work which you have done, or the project which we have done through the coding. Okay, so let's now go to the analysis part of this project. So if you see now the general statistics whatever we have done, I'll be just explaining them to you. Here we'll be calculate basic number that describes how far people uh, people live from green spaces. Okay, in layman terms, if we say, imagine you have surveyed 200 people in your neighborhood and ask how far do you have walked to reach the nearest park. Okay, some might say 100 meters, some might say 600 meters, as we are doing for 1 kilometer. So that's why I am taking these numbers. Or some will say like over 1 kilometer. Okay, we'll take all these answers and summarize them as four key numbers. Okay, so here it will be like minimum distance, that will be the shortest walk. Maybe someone lives right next to the park. Maximum distance, the longest walk, someone might live far from far from any green area. uh, Another will be the mean or the average, you can say the overall average distance across everyone. Okay, then the median, the middle value, like half of people work more than this, half of people work less. So we now look at what distance uh, data will be giving us. Okay, who is closest to the park, who is farthest, and at what average walking distance, for what will be the average walking distance, that will be the mean. And this tell us how green spaces are spread out, or if some people are getting left out. Okay, so after that we'll be doing the statistics like import matplotlib by plot and reproject it. Then we are adding the spaces and everything, the distances over here. So this will be provided like this: accessibility to green space. So here this is the main distance. Here you can say this is the 0 kilometer, this is the maximum distance. Okay, and you can see the points as well over here. So the points will be the residential points and the others are the green spaces areas based upon their park distance, or depending upon that. Okay, now applying see now the next analysis can be apply accessibility thresholds. Okay, uh, accessibility thresholds, you can say like so here after that we are basically plotting the same thing over in the map. if we'll say all the with the minimum and maximum distance, the shortest distance which is there. Based upon that, we are adding that to the map, the same data. Okay. So here you will see like this is the map area. Okay. Here's the particular neighborhood which is there. So similarly, we have added it to the map. Then the next, you can say that next one will be yes. So here the next code. So to generate this map, I'll just we can take, this is the code which we have written. Okay, that within that we can add it. So based upon that, you can change your code as well, and you can do it. Okay. Then similarly, we'll go for apply accessibility thresholds. So groups people into categories and based on how far they have walked. In layman's terms, I'll again explain it like, let's say the government says everyone should have a park within 500 meters. We now group the results into four categories, like people within 300 meters, great access. Okay, between 300 to 500 meter, good access. Between 500 to 1000 meters, like 1 kilometer, okay, but could be better. Means that is because I am saying these things because I am checking only on between 1 kilometer. So more than 1 kilometer too far, these peoples are undeserved. Okay, it's like storing everyone into color coded buckets, and now we'll ask like how many people are walking a distance, uh, how many people are within walking distance of a park. Okay, we break into the simple groups based upon the distance what we are calculating. So this will help us clearly see who has great access and who doesn't. Okay, so then here you can get these numbers, distribution of walking distance nearest to the green space. So mostly maximums has in between the lower bracket only. This is the distance. Okay, you can see that one is 0.4 kilometer, others are in between that, but most are in nearest only, whatever we have analyzed in this. Okay, so here is the distance part. Then this is basically, you can say, sorry, this is the code which we have written for that. Okay. Next will be cumulative access graph. So what is cumulative access graph which we are doing? So shows how many people live within increasing distance limits. Okay, on layman terms, now I'll again explain you. Like think of this as like a race to the park. Okay, we ask how many people live within 300 meters, how many people live within 500 meters, how many people live within 1 kilometer, and we'll plot those numbers on a graph. And this the more people reach to the park quickly, the stiffer the line, which means better access to the overall. Okay, how means the graph shows a cumulative percentage of people who lives within a certain distance of a green space area. So we can say the analysis after, like when we'll do it, like 60% of people are living within the 600 meters, 90% are 90% of people are living within 1 kilometer. So it is a big picture to view how workable the city is. So this is the example which I have given, like what do you mean by like a cumulative graph access or what it gives. So in our case, if you see, so to generate it, this is the code. Okay, so within this code you can say like this. So we have like 100% in between, like it has been increased uh, as you say. Okay, and accessibility summary, minimum distance is 0 kilometer, minimum maximum distance is 0.4, mean distance is 0.2 kilometers, and median distance is 0 kilometer only. It is easy. for them, means most of the people are nearest to the parks. Okay, so then accessibility levers within the thresholds we will see, you can check through this. So accessibility levels within 3 kilometers, that is 99%, within 5 kilometers, that is 100, within 1 kilometer 100. Because based upon we are taking a small area, like, so that's why it is taking. So if you are trying for a larger area, the numbers can change and you can do that. Okay, and as I can say, means we create a chat, so we create a pie chart visualization. It will be not a good pie chart, I'll say, because the numbers are very less. Okay, but you can create it through this particular code. Okay, and this is the result which I have got. So mostly everything is under the 300-meter, and then some of the part is this particular thing. But when the area is big, when the data is big, you can get a good analytics. Okay, so what this chart will be saying shows the percentage of people in each group using a pie chart. Like after we have grouped everyone, we'll make a pie chart. It's like slicing of a pizza, and each slice will have how many people are within the each access group. Like, for if you are getting a pie chart, you can easily visualize the data, like 40% of people are living within 5 kilometer, that will be a particular color. 35% are living within 1 kilometer, 25% will be living beyond 1 kilometer. That is, this is a quick visual snapshot. Okay, then now let's go to the final summary. Okay, you can write a final brief summary of what you are doing. So this is what I have created. So if you'll see, like, in the final summary, it will be giving a short report to it, like what's the average walking distance, what is the percentage people unreserved, what can city planners do. You can add these things as well. Okay, means so if you'll see, in our conclusion, on an average, people in this 1 kilometer area are 0.02 kilometers away from the nearest green space. 99% of the residents lives within the 300 meters, which is considered excellent accessibility. 100% are within 500 meters, and 100% are within 1 kilometer. Okay, so however 0.0% of residents are over 1 kilometer away, because we have taken only this thing. Okay, indicating undeserved zones that may require interventions. But yeah, see, the data is not big, so that's why this data can help city planners to identify green space gaps, prioritize future investments in urban parks and walkable public areas. Okay, so this is basically tells planners exactly where they need to act to make cities greener, healthier, and fairer. Okay, so now we can now go to the next section of it, that is, what are the real world applications of this project. Okay, how this can be used in our real world. So now let's talk on the real world applications of this project. The project can be a major impact in various fields. First is urban planning. Okay, it will help us to identify where to build new parks, new green corridors to enhance the accessibility. Okay, then the second one is health equity. Allow us to analyze if low income areas have poor green spaces, and make data driven decisions to improve the health equity. Second one will be the sustainability, supports urban lively uh, by improving the access to nature, which is key to buildings more sustainable cities. Then the in the smart cities, okay, you can combine this data with sensor or mobility data to create smart interventions like parks monitoring or improving the pedestrian walkability. Okay, so and okay, this is what I want to explain to you guys, and that's a wrap. We have successfully mapped urban green space accessibility in Berlin using Python and GIS tools. So, as I said, this will help urban planners to make data-driven decision for healthier and more accessible cities. You can use it in smart cities as well to create it a smart project. You can say if you have okay. So if you have enjoyed this particular video, okay, if you are seeing this video till this, I definitely think you are been into using this GIS project within yourself. So if you enjoyed this project and want to see more projects on this with the Pythons and GIS tools, so make sure you hit the like button, subscribe to this channel, hit that bell icon, and share this video as much as you can with your GIS enthusiast friends. Workflows. Thanks for watching. If you found this video helpful, give it a thumbs up, subscribe to the channel, and hit the bell icon to stay updated on the latest in AI and GIS. See you in the next video.